I'd like to take a moment to explain diffusion-weighted imaging. Diffusion-weighted imaging is a measure of how freely protons can move in the environment in which they live. The example I will use is a right MCA territory infarct. The initial image that we acquire is a T2-weighted image. It's called the B0 image. On this image, the CSF in the ventricle has a very high signal, the parenchyma has some lower signal, and then the region of the infarct has intermediate signal intensity. We then expose the brain to magnetic field gradients in multiple directions that rapidly change. The more freely protons are able to move, the more rapidly their signal drops in the setting of these gradients. After a certain amount of time, we acquire a second image, which we call the B1000 image. We can see that the protons in the CSF in the ventricles diffuse very freely, and their signal drops almost to zero. The signal from the protons in the parenchyma also drops, but not quite as rapidly as the CSF, because their diffusion is only mildly restricted. Finally, the tissue in the region of the infarction contains swollen cells and no longer has functioning sodium-potassium pumps. This results in almost no diffusion and no change in signal. As a consequence, on the B1000, or the diffusion-weighted image, the infarct appears bright compared to the rest of the parenchyma. Obviously, we can quantify the amount of change in signal that occurs as we go from B0 to B1000. If we were just to look at the slope, we'd say that the change in the ventricle CSF signal was very great. The change in the area of the infarction was almost zero, and the parenchyma was something in between. This would be the apparent diffusion coefficient. It's not exactly just the slope, but a measure of the natural log of the ratio of the signal at the beginning and at the end of our study over the B value we used, but it's still a measure of the relative change in signal. And this explains why we say an infarct will be bright on DWI and dark on ADC. Now, what is T2 shine through? Well, let's start with the same right MCA territory infarct for comparison, but add in a tumor that has very high signal intensity on the initial B0 image. As a consequence, when we look at the B1000, or the diffusion-weighted image, while the signal has dropped in the tumor, it hasn't dropped very far, and it still appears very bright. However, when we look at it on the ADC map, we can see that the change in signal intensity indicating that diffusion of protons is not being restricted in this area. This is called the T2 shine-through, because the signal that you see on the diffusion-weighted imaging is a consequence of the initial high signal intensity on T2, not because of the restricted diffusion of the protons in that region. I hope this helps you understand how diffusion-weighted imaging works and helps you understand why an infarct or an area of restricted diffusion will be high in signal intensity on DWI and low on the ADC, whereas other areas might appear high in signal intensity on diffusion-weighted imaging, but that would just be a consequence of their initial high signal intensity on T2, and they would still have high signal intensity on the ADC map.